Welcome to the deep dive. Today we're digging into a pretty specialized piece of hardware you sent over, the Aurora DTX-1616D. And our goal isn't just to, read off a spec sheet. We want to unpack how this one box, the 16 by 16 Dante signal processor, is designed to solve some really complex audio problems and simplify professional installations.
Yeah, that's exactly right. And let's be clear, this is not something you'd find in a home studio. This is high-end, networked AV for really demanding environments.
Like what kind of environments are we talking about?
Think large corporate boardrooms, university lecture halls, houses of worship, places where the audio just has to work. It's built to complement their video over IP systems and the fact that it's TAA compliant. Well, that tells you it's also aimed squarely at government and federal contracts.
Okay, so let's unpack that. At its core, it seems to be about bridging two worlds, right? You've got the 16 by 16 Dante networking, which is the digital side, but you also have 16 analog inputs and 16 analog outputs, all on terminal block connectors. For anyone listening, that's not your standard audio plug.
No, not at all. Those are for permanent, secure installations. You screw the wires in. The idea is that a cable can't just be accidentally unplugged in the middle of a critical meeting.
But wait a second. If you're putting all the inputs, outputs, and this huge suite of processing tools into a single box, isn't that a massive single point of failure? It must need some serious horsepower under the hood.
And that is the key question. They've absolutely thought of that. It's powered by not one, but two ADI Shark processors.
Two of them.
Two. It's completely over-provisioned. That dual processor setup means it can run everything simultaneously. All the routing, all the EQs, dynamics, everything with, basically zero latency. It's built for reliability.
So a big part of the pitch here is about simplification, reducing the number of devices in a rack, cutting down on cabling costs. How does the software side of it deliver on that?
This is where it gets really cool. It all comes down to the adaptive processing.
Moment.
Exactly. Think about the last time you were at an event and heard that awful high-pitched microphone squeal. This box has AFC, or adaptive feedback control, which just eliminates that. It hunts it down and kills it.
And for something like a conference call?
That's AEC, adaptive echo cancellation. It stops the people on the other end of the call from hearing their own voices echoing back at them. It's absolutely essential.
Okay, so it solves the big dramatic problems, the feedback squeal, the echo.
Yeah.
But what about the more common stuff, like, when you have one person who talks really quietly and the next person practically shouts into the mic?
It handles that too. That's a combination of AGC, automatic gain control, and AMC, automatic mixture control. They work together to keep the volume level consistent across all the different speakers.
So the person running the system doesn't have to constantly ride the faders?
Precisely. And then there's ANS, automatic noise suppression. That's for filtering out the constant background drone from things like air conditioning systems or projector fans.
I saw a note about a built-in USB sound card. Is that just for recording, or can you say, plug a laptop straight in for a video call?
You can, yeah. It acts as a direct link for soft codec, so it becomes the central hub for Zoom, Teams, whatever you're using. Add in 16 presets for different room setups and programmable ports for physical controls, and it really is the brain of the room.
But we have to talk numbers. Pristine audio is a great marketing term, but what does it actually mean in the specs?
Right. The numbers tell the real story. System latency is under 6 milliseconds. To put that in perspective, that is completely unnoticeable. There's no lip sync delay.
That's incredible.
It is. And the signal-to-noise ratio is 110 dB, so the audio is incredibly clean, very little background hiss. The distortion, or THD plus N, is less than 0.0003%. I mean, it's just vanishingly low.
So what does all this mean for you, the person actually designing or installing one of these systems? This deep dive really shows how these specialized DSPs are making complex setups, well, simpler.
They consolidate so much. You get higher fidelity audio in, say, a lecture hall or boardroom, but with a much more manageable and cost-effective installation.
Which brings up a pretty interesting final thought.
It does. I mean, if this whole ecosystem is built to reduce devices and cabling by leaning on digital standards like Dante, it makes you wonder, how much longer until professional AV systems are almost entirely networked?
Making analog connections just a legacy option for older gear.
Exactly. Something to think about for your next project.